So today we're going to be looking at drawing atoms and reminding ourselves how to draw atoms. These are going to be really important for us as we continue on with chemistry to understand how bonding works. So to draw atoms, we're going to be using what's called a Bohr-Rutherford diagram to start. Bohr-Rutherford diagram shows the location of all subatomic particles. So it shows the location of electrons, it shows the location of protons, and it shows the location of neutrons. You will have to remember how to calculate each of these numbers. So in order to figure out the number of protons, you want to look at the atomic number on the periodic table. The atomic number is this number that's in the top corner. If you're not sure if it's the atomic number is always a smaller number. So the atomic number is always smaller than the mass number, and it's that nice whole number. So number of protons is equal to the atomic number. In neutral atoms, number of electrons is also equal to the number of protons. So by looking at this atomic number, you can actually state the number of electrons, and you can also state the number of protons. Last thing you want to figure out is the number of neutrons. So the number of neutrons, you have to do a little bit of math. Number of neutrons is going to be the mass number minus the atomic number. Now, there is a mass number here. There are decimals, so you do want to round this to the closest whole number. So here it's 6.941, so we would round this to 7. So in order to figure out the number of neutrons for lithium, we would take the larger number, 7. We would subtract the smaller number, 3, and that's going to tell me that I've got 4 neutrons. Just a few steps in order to help you calculate your Bohr-Rutherford diagrams. You want to have your periodic table handy, and the first thing you want to do before you start drawing is you want to calculate your number of protons, neutrons, and electrons. Once you have those, you're ready to actually start drawing your atom. You want to start by drawing the nucleus first. You're going to draw the nucleus by writing the symbol of the element, and you're going to indicate the number of protons and the number of neutrons. That's because both protons and neutrons exist in the nucleus. After that, you want to draw the electrons in their orbits. So remember, they exist in orbits as circles around the nucleus. A couple of rules when you're actually filling the orbits. You always want to fill the lowest orbit first. You always want to start in the circle that's closest to the nucleus and then move out as they get full. The first orbit can only hold 2 electrons. So your first circle is going to have 2 electrons. The next one is going to have 8, and the next one's going to have 8 after that. These rules will work up until calcium. We're actually going to learn a new way to draw atoms in grade 12. So Bohr-Rutherford model is going to work for grade 9, grade 10, and grade 11 chemistry. And in grade 12, I'll teach you the updated model of the atom. So here, why don't we go ahead and we're going to draw a Bohr-Rutherford diagram of helium. So you're going to pause to get your periodic table. I'm going to pause to get my periodic table, and let's do this together. So just a reminder that you do have that interactive periodic table in your widgets. If you're not sure how to get there, just view the periodic table video again. That's before this. It's going to remind you how to get there. So what we should see from the periodic table is, I'm just going to record the information here. From a periodic table, you're going to see that the mass of helium is 4 and the atomic number is 2. So I just recorded this in what we call standard atomic notation. We learned that again in grade 9. So standard atomic notation just has your element symbol. It has your mass at the top. It has your atomic number at the bottom. And it's just really all the information you need to draw a Bohr-Rutherford diagram. Now I'm going to go ahead and I'm going to calculate my number of electrons and also my number of protons. My number of electrons in this case is going to be the same as my atomic number, so it's going to be 2. My number of protons is also going to be the same as my atomic number, so it's going to be 2. And then my number of neutrons is going to be what I have to calculate. So my number of neutrons is going to be my mass, which is 4, minus my atomic number, which is 2, and that's going to give me a total of 2. Once I've got this calculated, I'm now ready to start drawing my Bohr-Rutherford diagram. So my Bohr-Rutherford diagram, I want to put my element symbol in the middle. I'm going to record my number of protons and my number of neutrons, because remember, those are my 2 subatomic particles that exist in my nucleus. Now notice that protons and neutrons are the same number in this case, not always the same number. But in this case, they happen to be. So don't assume, always do the math, but a lot of the time they do end up being the same number. Now I'm ready to start placing my electrons. So I'm going to place my first orbit. Remember, circles are not my strong point. It's very hard at a computer. There we go. Beautiful. So that's my first orbit. So I'm going to go ahead and I'm going to place my 2 electrons on here. Remember, you actually have 2 options for placing your 2 electrons. We have the way that is consistent with our grade 12 model. That's an electron at the top here and an electron at the top here. You could have also placed an electron at the top and an electron at the bottom. Both are considered right in grade 10. The reason I do the 2 at the top is because the model I'm going to teach in grade 12 would have placed the 2 at the top. Now I'm going to go ahead, I'm going to hit pause. I want you to look up the information for nitrogen, and we're going to go ahead and we're going to draw nitrogen together next. So all I've done is just recorded the information from the periodic table for nitrogen. The symbol for nitrogen is N. The mass is 14, and the atomic number is 7. So I'm going to go ahead, I'm going to calculate my protons and my electrons first. Not really much to calculate, because remember, this is the same as my atomic number. So I've got 7 here, and I've got 7 here. To calculate my neutrons, I'm going to take my larger number, my mass number, which is 14. I'm going to subtract from it my smaller number, my atomic number, which is 7, and that's going to give me a total of 7 neutrons. Now I'm going to put my symbol in the middle first, and then I'm also going to list my number of protons and my number of neutrons, because those are the 2 subatomic particles that exist in the nucleus. We happen to have the same number again, both 7. Now I'm ready to start placing my electrons. So I'm going to put my first circle around the outside, and I'm going to place my first 2 electrons. Remember, my first shell, my first orbit can only fit 2 electrons. I'm going to put the 2 of them at the top here. Now that the shell is full, I can move on to the next energy level. So to draw the next energy level, I'm just going to draw a second shell around this atom. Just a reminder of how many electrons I'm trying to place. I'm trying to place 7 electrons. Right now I've placed 2. So on this shell, I'm going to place 5 total. Now you do want to be careful where you start placing them. So remember, you always want to follow the order. I'm going to start at the top, 1. Then I'm going to go 2, 3, 4. Once each side has received an electron, then I can go ahead and I can start pairing. So you do have to make sure you follow that order. If you don't, I can tell, and it is technically incorrect. If you had just gone 1, 2, 3, 4, 5, your outside shell would look different than this. This is the correct outside shell, so always place 1 electron on each side before you start pairing. So what I want you to do next is we're going to hit pause, and you are going to try to draw your diagram for boron. So hit pause, try to draw boron yourself, and I'll come back in a second and I'll take that up with you. So here I've recorded my information for boron. Chemical symbol is B, and boron actually has, we rounded up this time, so boron has a mass of 11, and it's got an atomic number of 5. So I'm going to go ahead and I'm going to record my number of protons, my number of electrons, and my number of neutrons. My number of protons is equal to my atomic number, which is 5. My number of electrons is also equal to my atomic number, so also 5. And for my number of neutrons, I'm going to take my mass number, 11. I'm going to subtract from it my atomic number, 5. And I'm going to find that my number of neutrons is 6. So for the first time, our number of neutrons is actually different. I'm going to put my chemical symbol in the middle, and my 2 subatomic particles that exist in the middle are number of protons and number of neutrons. So I have 5 protons, and I have 6 neutrons. Now I'm going to place my first shell around the outside of boron. So remember, my first shell can fit 2 electrons, so I'm going to go ahead, I'm going to put 1 electron here, and I'm going to put 1 electron here. Now this energy level is full, so I'm going to go ahead, I'm going to place another shell. Now remember, I'm trying to place 5 electrons. I've already placed 2, so left is going to be 3. So I'm going to start at the top, 1, I'm going to go to the side, 2, and I'm going to go to the bottom, 3. So that's how you draw Bohr-Rutherford diagrams. You have a practice assignment this week where you're asked to go ahead and practice drawing Bohr-Rutherford diagrams. I'm going to hit pause and I'm going to show you a shortcut to Bohr-Rutherford diagrams that's going to be very useful. So that's Bohr-Rutherford diagrams. That's how you're going to draw them in your assignment. Next up, I'm going to show you Lewis structures. So join me back here in just a second. So here we're going to take a look at how to draw Lewis diagrams. It's a shortcut that's going to be useful for us in grade 11 and grade 10. So just a little bit of background information. When atoms combine, so we're going to be looking at forming compounds starting next lesson. So when atoms combine, only their outside or their valence electrons are involved. So whatever's on that outside shell is what's involved in chemical reactions. So really that's the interesting part. That's what we care about. So we can actually represent these valence electrons with Lewis diagrams, which are also called electron dot diagrams. Lewis diagrams are a very simple way for you to understand and look at just the valence electrons and understand how things will chemically form compounds. Lewis diagrams are a little bit different. So Lewis diagrams, the nucleus is just going to be the element symbol. So instead of actually recording using plus signs to represent positive charges, the element symbol represents the nucleus. So what this means is rather than having protons or neutrons listed in the nucleus, we really don't care about protons and neutrons in terms of chemical reactivity. So all we're going to represent is the element symbol. That's it. Around that, you're going to draw dots, one for each valence electron. So you don't have to draw those inside shells anymore. All you have to do is go ahead and draw the number of valence electrons, those outside shells. The dots are going to be spread over all 4 sides. Dots are not paired until the sides have at least 1 dot. So this is the exact same as what we did with Bohr-Rutherford diagrams. You're going to place a dot at the start, at the side, at the bottom, at the other side before you start pairing. The number of valence electrons is equal to the group number. So just by looking at the periodic table, you can tell the number of valence electrons. Anything in group 1 has 1. Anything in group 2 has 2. And then we skip to column 13. Column 13 has 3. 14 has 4. 15 has 5. 16 has 6. 17 has 7. And 18 has 8. Those middle groups that we missed, so 3 to 10, we're actually going to cover in a couple lessons. So right now we're going to miss that middle group on the periodic table. We're just going to be focusing on those that form regular ions. Drawing Lewis electrons help us to identify an electron pair. So what an electron pair is when 2 electrons are together on one side of the atom. So it helps you to look at the electron pairs, which are less reactive. It also helps you to identify unpaired electrons. That's when you just have a single electron on the side of the atom. These tend to be very reactive. So we're going to go ahead and we are going to take a look at how to draw Lewis diagrams. We're going to start by drawing a Lewis diagram for oxygen. So the first thing that you're going to want to do is you're going to want to find oxygen on the periodic table. You want to figure out how many valence electrons it has and also what the chemical symbol is to represent it. So I'm going to give you a second to go ahead. I would look in group 16. So hopefully you found that oxygen has the chemical symbol of O. So we're going to use O as our nucleus and that's it. Now we're going to place 6 electrons because oxygen is in group 16. That means it has 6 valence electrons. So I'm going to start at the top here, 1. I'm going to go to the side here, 2. Bottom, 3. Side, 4. Now I can start pairing. So I'm going to go to the top again, 5. And I'm going to go here, 6. I now have my Lewis diagram for oxygen, so I can see that I have 2 electron pairs and 2 unpaired electrons. I want you to pause the video and I want you to try your Lewis diagram of neon. So hopefully you saw that neon has a chemical symbol of Ne. So to represent the nucleus, I'm just going to draw an Ne. Neon is in group 18, so that means it has 8 valence electrons. So I'm going to start at the top here. I'm going to go to the bottom. Or side. Now I'm going to go to the bottom, side, top, side, here, here. So I can see that neon has 8 valence electrons. All of them are actually electron pairs. Neon actually is considered to be full, so it's going to be very on-reactive. It's not necessarily going to want to gain or lose electrons, so it's not going to react chemically. Last thing I want you to do, pause the video, go ahead and look at your Lewis diagram for sodium. So sodium, you should have seen, has a chemical symbol of Na. So it's kind of one of those surprising ones where the chemical symbol is different than the English name. And sodium is actually in group 1. Since it's in group 1, it's only got 1 valence electron. So we're going to go ahead and place that electron at the top here. Since it has only 1 valence electron, it is actually extremely chemically reactive. It's an alkali metal and it's going to react very violently. We talked about these a little bit in your periodic table review. So that's it. That's Lewis diagrams. You do have to know how to draw both. So in your assignment, you are asked to draw Bohr-Rutherford diagrams. You're also asked to draw Lewis diagrams because they're a great shortcut and they help us see how things are going to bond chemically. Join us next lesson and we're going to be talking about how to form ions.